Hi guys, we are from Group 4. The group members are Mo Oi King, Boon Chu Kim, Muhammad Alif Akram, Mak Jendat, Patricia, Chelsea, and Chan Fong Chi. Our group are mainly study about the Hong Kong particular specification for utility survey and mapping. Besides that, we are also going to compare the utility survey and mapping in Malaysia and Hong Kong. The topic that we will discuss in this presentation includes the background issue of utility survey between Hong Kong and Malaysia, the survey requirement, the quality level of utility survey, the personnel requirement, mapping database and format, the particular specification that's stated in the guideline of underground utility survey that published by Hong Kong and Malaysia. In Malaysia, the Department of Survey and Mapping Malaysia, JUPEM, serves as a government agency that is responsible in managing the geospatial information. JUPEM has been entrusted by the government to compile and manage the information on all underground utilities. Besides that, JUPEM also serves as a guideline provider for the underground utility survey in Malaysia, as it had published 3 guidelines which were the standard guideline for underground utility survey in 2006. This was done to provide a standardized method and specifications of the underground utility survey, as well as the collection, compilation, and the presentation of the underground utility data. The guideline also addressed the issue about the roles of stakeholders and the quality level of utility survey. The latest publications were Guideline for Underground Utility Survey and the Guideline for Survey of New Utilities in 2007 and 2013 respectively. Hence, the Hong Kong Institute of Utility Specialists (HKIUS) have been established for handling the issue about the underground utility survey. It is a non-profit making organisation in Hong Kong which is contributing in the training for the underground utility survey. They have published the pamphlets and guidelines for the utility specialists in 12 sectors, and also the method statement and the particular specification in conducting the utility survey.
Other than land and strata titles, geodetic survey, engineering survey, topographical survey, hydrographic surveys, and map making, land surveyors in Malaysia had always been updated to the current demands on survey technology. As the urban sprawl happening on the surface of the earth, it also rooted the human civilization under the ground due to the facilities of utility systems such as electric cables, water, sewage and gas pipe, telecommunication line are buried underground in high density. In Malaysia, utility agencies are private entities or government-linked companies. Currently, among the main players in these companies are Gas Malaysia Sendirian Berhad, Tenaga Nasional Berhad, Telekom Malaysia Berhad, Syabas, Indah Water Consortium Sendirian Berhad, and for Sabah Sarawak Petros, Sarawak Energy, Sabah Electricity, Lembaga Air Kuching, and also Jabatan Air Negeri Sabah. Hong Kong has a densely populated city, which indicating that the facilities of utility system should have experiencing highly development to cope with the public demands. On 23 July 1994, a disastrous landslide happened in Kung Lung Lau in the western area in Hong Kong Island. This has led an investigation to find out the cause of the accident. After the Kung Lung Lau incident, more and more surveys regarding utilities were requested by the market, especially for those on the slope. During 2000 and 2002, a steering committee chaired by King Wong completed the formation of HKIUS by registering a society with Hong Kong Police Force in 2002, and HKIUS was formally established on 1st April 2003 by its first committee.
Next, we'll talk about the role of JUPEM and HKIUS in underground utility mapping. So, JUPEM's involvement in utility mapping began with the directive from the Malaysian Cabinet to compile and manage the information on all the underground utilities for the country. JUPEM later acquired a utility mapping system and developed a national underground utility database called PADU. PADU also stands for Pangkalan Data Utility Kebangsaan. The establishment of PADU allowed the reliable and accurate centralizations of the underground utility data comprising power and telecommunication cable, gas, water, and sewerage pipe provided by the utility agencies in a systematic geographic information system approach. For Hong Kong, in over 15 years, HKIUS has taken the initiative for discussion on utility survey, utility safety and management, its industry and its membership issue with some of the departments of its country. So the first department is a Architecture Service Department, followed by Building Department, Civil Engineering and Development Department, Drainage Service Department, and so on. To proceed to the survey requirement for both Malaysia and Hong Kong. For the techniques in underground utility mapping in Malaysia, we mostly use the subsurface detection. It is a non-invasive techniques and electromagnetic techniques. Underground utility installed inside the utility facilities, route in which the situations is common trenching, common utility tunnel, and horizontal directional drilling. So for the equipment we use, it's called PCL, GPR, GPS, and total station. For the calibration part, all the instruments should be calibrated at a certain durations of time according to the JUPEM guideline. Calibration for gyro base refer to the manufacturer. So for the survey interval, the height measurement from mean sea level should in 20 meters interval. So for the measurement of topographic detail, is up to 10 meter left and right of the installed utilities. So the technique they use in Hong Kong for utility mapping is called non-destructive methods to estimate the location of the buried utilities. It's same with the Malaysia is also the electromagnetic detection. The footprint of such features and route and pavement level shall be recorded in 3-dimensional. So next, the equipment they use is called PCL and also GPR. So for the calibration part, all instruments used in the investigation shall be recently calibrated and a copy of the calibration certificate shall be supplied to the engineer. So next, the survey interval that they require is underground utility service shall be located continuously and recorded in 3-dimensional, which not exceed 5 meter interval discrete areas. The second, interval not exceed 10 meter for survey along the routes and at each survey's features change of directions and verification.
Okay, so for Malaysia uses 4 different quality levels, namely quality level A, B, C, and D to represent the accuracy of the survey utility data. So what is done in quality level D is that they search for existing utility records and prepare utility composite drawings in digital and hard copy form. Whereas for quality level C, it is the checking for existing utility above ground, checking for accuracy of survey and completeness of information, while quality level D is not compulsory for quality level C. Quality level B involves the non-invasive detection, marking an indication of presence of underground utilities to the accuracies and precisions as stated in the guidelines, while quality level A is the verification of underground utilities by looking at exposed utilities such as as-built and test holes, and also the usage of calibrated survey equipment and surface geophysical detection equipment must be used to acquire quality level A data. Okay, so for Hong Kong uses 3 different accuracy levels to represent the accuracy of the survey data. These are accuracy level high, medium, and low. So the accuracy levels represent a function between the sample points on locatable surfaces with respect to the grid control points and benchmark data with a certain tolerance. Like for example, if it's low, then it's 80% with around 0.3 accuracy level. Therefore, the position on and level of locatable surfaces at the recorded points and intervals must be related to grid control points and benchmark to determine the accuracy level of the data. Okay, next, for personal requirement, there are only 3 types of individuals in Malaysia that can carry out underground utility survey. These are licensed land surveyors registered under the Licensed Land Surveyors Act 1958 with either a certificate of competency in underground utility detection and mapping (CUDM) or a certificate of competency in underground utility detection survey (CUDS). Besides that, a director of survey utility mapping division or the director of survey for each state can perform underground utility survey, as well as preparing, signing and approving underground utility plans and the relevant SP plans, as well as above ground utilities and approving above ground utility plans and the relevant SP plans. Licensed land surveyors without the relevant competency certificates can only survey above ground utilities and approve above ground utility plans and relevant SP plans. Okay, whereas for Hong Kong, the personnel responsible for utility surveying and report preparation shall hold a certified qualification issued by either the RTO, registered training organizations such as Utility Training Institute (UTI) or the Hong Kong Polytechnic University, or any equivalent that is approved by HKIUS. So the certified qualifications include either degree, professional diploma, professional certificate, or any equivalent approved by HKIUS in utility surveying and management or related subject awarded by RTO, such as the Utility Training Institute or the Hong Kong Polytechnic University.
I will carry on to discuss about the difference in mapping database and format between Malaysia's JUPEM and Hong Kong Institute of Utility Specialities. Number 1 is the layer. In Malaysia, the data is separated into layers based on the quality level. Meanwhile, in Hong Kong, it is based on the specification of contractor and approved by engineer. Number 2 is annotation. In Malaysia, the annotation is appropriately used to ensure that it does not obscure other utility data. In Hong Kong, it is plotted at the same Z value as their respective features using correct aberrations. Number 3 is detail on plan. In Malaysia, we include details like parcel boundaries, lot numbers, name of building, street, and rivers in the plan. Meanwhile, in Hong Kong, it includes building lines, roads with road name and traffic lane, road marking, pavement and curbs, and other significant physical feature in the survey area. Number 4 is the marginal information. In Malaysia, it includes section, town, city, and state names, scale, north arrow, legend, published data, disclaimer, and map index. In Hong Kong, the layout and border and also the title block is also referred to the engineer. Lastly is the datum use. In Malaysia, the horizontal datum use for utility mapping is geocentric data of Malaysia, GDM 2000. Meanwhile, the height is based on the national geodetic vertical datum. In Hong Kong, the horizontal datum is their geodetic datum, which is HK80, Hong Kong 1980, and the height is based on Hong Kong principal datum.
So here is the Malaysia color codes. As you can see at the table, there's types of utility, code, and color. So for the first one is for electric cable, the given code was P and the color given was red. For the second one is water pipe, so the given code was W and the color was blue. So for the third one is gas pipes or petroleum, so the code is G and the color is yellow. So for the telecommunication cable or any including fiber cable, the given code was P and the color in brown. So for the sewage pipe, the given code was S and the color is in green color. So for the Hong Kong color codes, as you can see at the table, as example that I can say, take a look on fourth row for the first column, which is HK Electric. They use different kind of voltage with different kind of color coded, and so on.
Next, we go to the specialty between guidelines in both countries. First, I will talk about Malaysia. Malaysia guidelines consist of two, which are PADU and quality levels. Okay, I will talk about PADU first, Pangkalan Data Utility. It combines with other geometric-based data such as cadastre data, topographical data, location data, as well as other details relating to the utilities. Second, quality levels. In Malaysia, quality levels based on ASCE standard 3802, which divides the quality levels into 4 different levels, which are quality D, quality C, quality B, and the best, quality A. Each level represents the methodology of survey used to map the utilities underground. Hong Kong also have 2 guidelines, which are, for the first one, accuracy levels and inspection personnel. For the accuracy levels, Hong Kong adopts general accuracy level based on sampling of the in-plan utilities and comparing the position of utilities to the grid marks and benchmarks on ground. The percentage of utilities sampled and the difference of the position of utilities determines the accuracy levels have 3, which are low, medium, and high. Okay, the second one is inspection personnel. It must be accredited according to HKIUS standards with minimum training requirement and years of practical experience as detailed in the specification guidelines. I will show you about the example of utility mapping in Malaysia. Okay, basically, Malaysia utility mapping will consist of compass, northing, easting, the government, licensed surveyor, the symbols and the descriptions, and many more. Okay, but different with the Hong Kong utility mapping. Hong Kong utility mapping did not stated about compass, northing, easting, the symbols and description, the licensed surveyor, chop, their government, their scales. It's not stated there. It's not like Malaysia utility mapping. These are the references that we use for our group presentation. Hope you guys enjoy. That's all. Thank you.